Hi there, I'm Miss Shi from Geometry, and today we are doing Pythagorean theorem. This is something that you might be familiar with from your previous years, either in middle school or a previous math class, but today I'm going to really frame what Pythagorean theorem means for our class, specifically in this unit. So, if you take a look at the screen, there's a couple of things. One, I want on the left here, I want you to realize that there is some vocabulary that we're going to use, and the vocabulary is going to be right triangle. We're going to talk about hypotenuse, legs, sides, Pythagorean theorem, and the converse statement of the Pythagorean theorem. So as a heads up, that's coming up. And hopefully by the end of this video, you can tell me which side is the hypotenuse. You can apply the Pythagorean theorem to the missing sides to find missing sides of a right triangle. And you can determine if a triangle is even a right triangle at all using the converse statement of the Pythagorean theorem. So we have a lot to learn. Let's get started. You better get used to having a right triangle. All the triangles in this next unit are going to be right triangles. Maybe you have to prove that they are right triangles. So if I were just to give you a blank triangle and say it's a right triangle, automatically, how we have always done it for many, many years is that we identify one side as A, one side as B, and one side as C. Now, the important thing is C is almost always identified as the hypotenuse. Almost always. I would say anytime I'm going to write C, it's going to represent the hypotenuse in this case. What is special about the hypotenuse? To hit the first objective of this video, you need to know that the hypotenuse is the longest side of a right triangle. Is the longest side of the right triangle. If you're doing your notes correctly, you will identify the vocabulary words in some way that you're annotating. You can either highlight your vocabulary words or write them in a different color. Have fun with it. Make your notes your own. But the hypotenuse is the longest side of the right triangle. And I say that now, and it may seem a little obvious, but that will help you in the future when you're trying to orient yourself, because a triangle may be rotated or reflected, and you need to find which one is the hypotenuse to ground all your work for this unit. Great. A and B are they are the legs of a triangle. Sometimes they're equal to each other, sometimes they're not. If they are equal to each other, that forms like an even more specific right triangle. So for example, just really quick, if you do have a 90-degree right triangle and these are both the same length, then that means that both of these angles also have to be the same because you form an isosceles triangle. This is a special right triangle. We're going to get into this more eventually, but just as a heads up, A and B sometimes can equal to each other. A can be larger than B, the value of B can be larger than A, but A and B together have to be greater than C. So your legs, A and B, have to be greater than your C value. They can't even be equal. It has to be greater than. And in this case, for a 90-degree angle, they're definitely always going to be greater than C. However, C by itself is always going to be larger, always larger in length than B or A. Okay? Hypotenuse, longest side of the right triangle. First objective, done. Let's move on. Let's get into some examples of, you know what I should probably do? I should probably tell you what the Pythagorean theorem is. So in your notes, I'm going to get rid of some work here, like this stuff. But in your notes, you are going to write down, what is the Pythagorean theorem? What is the Pythagorean theorem? If you already know the Pythagorean theorem, that's amazing and brilliant. So Pythagorean theorem. I hope you enjoyed the video on a proof of the Pythagorean theorem. There's so many proofs of Pythagorean theorem out there, and go research your own fascinating stuff. So if this is a right triangle, if one of the criteria for the Pythagorean theorem is it must be a right triangle. It must be a right triangle. So if this is a right triangle, then you may apply the Pythagorean theorem. And the Pythagorean theorem is if you square the legs of the triangle, that's going to equal to the hypotenuse squared. So A squared plus B squared is C squared. So if I ever ask you to apply the Pythagorean theorem, this is what you're going to apply. You're going to write A squared plus B squared equals C squared and then solve for the missing side. So let's practice. Here is our first example. So we have example 1. Example 1, solve for any missing side. So we have a 3 and a 4, and we have this missing triangle. This is a special triangle. It's near and dear to my heart, and this is going to come up all the time because I'm not creative, and this is my right triangle of choice. So let's practice. A is equal to 3 in this case, B is equal to 4, and C is equal to something. So I'm going to rewrite my Pythagorean theorem up here. A squared plus B squared equals C squared. And I'm going to fill in my values. Something squared plus something squared is equal to something squared. Now, at this point, you're probably really proficient in working on your algebra and evaluating, but I'm writing it out purposely in this way so that you can see it's the side length squared. It doesn't necessarily have to be 9 plus 16 is equal to 25. It's something squared plus something else squared is equal to something else squared. All right, so we get to this, we combine like terms. Remember this, you take the square root of both sides and you get plus or minus 5. Technically, you get plus or minus 5. However, and you can write this down as a little asterisk in your note, you won't have a negative side length because we're talking about length. It's always going to be positive. So take the absolute value version and then take the positive version of your square root. But technically, this should be plus or minus 5 algebraically. But one of the solutions is extraneous. Okay, so C is equal to 5. 3, 4, 5, easy to remember, right? This is a very special Pythagorean triple. We will talk about this more. Remember this triangle, 3, 4, 5. Easy to remember, 3, 4, and 5. Okay, here's actually another special right triangle. This is example 2. You should take some time as I'm talking right now to sketch in this triangle. You can even pause it right now, sketch it in. I see an isosceles triangle. I see a right triangle. I see a right triangle. I can apply the Pythagorean theorem. All right, so A is equal to this. B is also equal to 7. What is C? So we're going to apply something squared plus something else squared is equal to C squared. Okay, so 7 and 7. So this is 49 plus 49 is equal to C squared. And this is equal to 98. 98 is equal to C squared. So when you take the square root of this, 1, ask your teacher, can you leave it as a square root of 98? It depends on your teacher if he or she will let you leave it like this. I'm okay with this sometimes, but more importantly, you won't be able to find a multiple choice selection if you just leave it as a square root of 98. You won't, if it's a multiple choice question, you won't. But let's break up, this is 2 times 49. 98 is 2 times 49. This is extra. This is a little preview. 2 times 49, which is 7 times 7. So if you multiply 2 times 7 times 7, you're going to get 98. How do I know that? Because it's 2 times 49. 49 is 7 to 7. Okay, so if this is if this is C, because the square root of C squared is just C. I see this. So I'm going to take this out. So 7 root 2. You like my radical practice? Yeah, refresh your memory on that. I'll have another video for that. All right, so 7 root 2. So 7 is equal to 7 root 2. Now, most of you are actually just going to punch this into your calculator and you're going to get 7 times root 2. I prefer, my preference as a geometry teacher is that you leave it in radical form because I have you practice doing this with algebra. Ask your teacher if you can use decimals. If you use decimals, please round to a certain number of decimals so that it has enough significant figures. Ask your teacher but please for me, if you can, simplify the radicals. Okay, all right. So this was solving for the hypotenuse, the last 2 examples. Example 1 and 2 was solving for the hypotenuse. So solving for hypotenuse, H, the hypotenuse. Let's try to solve for not the hypotenuse. So example 3 is not the hypotenuse in this case. The hypotenuse is actually 10. So we have a squared plus b squared equals c squared. And this is a little different. A is equal to 8. C is equal to 10. So what does b equal? So again, we have something squared plus something squared is equal to something squared. Now, we know what a is and we know what c is, but now we have to solve for b squared instead of c squared. So notice it's a little bit different. It's on a different side of the equal sign. So I'm going to leave it like this, and 100 And I'm going to say b squared is equal to 36. And I only know this is 36 because it's actually a dilation of my favorite right triangle. Anyway, so if we take the square root of b squared, we're going to get b is equal to plus or minus 6. But because it's a distance, we can throw out the minus 6. And we're going to get plus 6 here. All right? 6? Yes. So 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. This seems to be a dilation of a 3, 4, 5 right triangle, just to tie it back into the last unit. Okay, again, this is example 4. Let's do this once more where we can solve for the missing side. So the missing side, again, is not the hypotenuse. So the hypotenuse in this case is 9. This is going to be A, and this is going to be B. You can call this B, and you can call this A. That's okay. So this is going to be something squared plus B squared is equal to something squared. Oh boy. All right. I think this is 225. Plus B squared is equal to 81. Oh, what did I do, folks? See? What did I do? My hypotenuse should be the longest side. Do you see what happens here? You get a negative number. This is a good mistake. And watch, I'm not even going to cross it out because I know that bothers people. All right. Boom, boom. Hypotenuse. C, man. Sorry, I was a little distracted. A is equal to 9, and B is still equal to something. So A squared is equal to 9 squared. See, it's going to make errors. But look, I crossed it out. I didn't erase it. It's not great. All right, 81 plus B squared is equal to 225. 220 plus 15 times 15. Okay, minus 81. All right, it's 144. Nice. All right. B squared is equal to 144, and the square root of 144. Wow, I can't believe I didn't say this is why. The hypotenuse is the longest length. B is equal to positive 12. Technically minus 12 too, but it's extraneous. Okay, so positive 12. So that is how you solve for a side. Solve for a side, not a hypotenuse. Okay. Now, finally, to hit the third objective, let's figure out how do we even know? We need the converse of the statement. So far we have this statement. If the triangle is a right triangle, then we can use a squared plus b squared is equal to c squared. Let's do the converse of that. Let's do the converse statement is if, oh boy, a squared plus b squared is equal to c squared, then the triangle, the right triangle. So this is the converse of the Pythagorean theorem, but it also applies. So if a squared plus b squared equals c squared, then the triangle is a right triangle. This is the converse of the Pythagorean theorem. Very important. So let's apply the converse. Let's see if these triangles are right triangles. Okay. It looks kind of like a right triangle, but don't make assumptions. That is the downfall of a lot of our geometry students, is making assumptions. So we are not allowed to assume. But let's test. Is a squared plus b squared equal to c squared? Is it? Maybe. Now, the longest side is the hypotenuse, as I incorrectly did previously, but now we know. So technically, if there was a hypotenuse, it would be 13. Okay, let's just see. So is this equal? Is 5 squared plus 12 squared equal to 13? This is 25, this is 144, and this is, 156? Okay. 169, okay. So is this equal? And 25 plus 144 is indeed this number. So yes, so you could write yes. Whoa, why is this all the way over there? So you can say yes, this triangle is a right triangle because a squared, b squared does equal, because a squared plus b squared equals c squared is true. Yay. Great. Let's do it once more, and then we can summarize our notes for the day. All right, here's a triangle. It looks like a right triangle, but you can't assume. So now we're going to test, is a squared? So let's apply the converse statement. If we prove that a squared plus b squared is equal to c squared in this case, then this triangle is a right triangle. Let's see. Is a squared plus b squared equal to c squared in this case? Okay, the longest side is the hypotenuse. The longest side of a right triangle, if this is a right triangle, will be the hypotenuse. So let's try 9 squared. So we're going to call this A, B, and C. Either way, this won't work, whatever order you do this. But 6 squared plus, oh, did I spoil it? Sorry. Is this true? Is this true? Is 100 equal to 81? No. So your statement, if I had you prove, is this triangle a right triangle? You would be able to say, no, this triangle is not a right triangle, because you can say a squared plus b squared, a squared plus b squared equals c squared is not true. All right. Yay, you have reached the summary portion of our notes. Congratulations. I'm going to actually go back up to the objectives so that you can summarize the objectives. I want you to write a summary at the bottom of your notes. If you go back, make your notes personal, make them your notes so that I can see them the next day. But one, summarize, how do you know which side is the hypotenuse? How do you apply the Pythagorean theorem to find missing sides? And third, I don't know why I'm pointing at my screen. I need to point here. And third, how do you determine if a triangle is a right triangle? So I'm going to leave the screen here. You can pause, but summarize your notes, and I will check them in the next class. Have a great day. Bye, everyone.